Okay, we now need to look at our analysis questions and help explain this phenomenon to the best of our ability. So, as you remember, we had our wand, okay, and our wand had that foil draped over it, and the foil somehow was charged or manipulated in some way until it began to expand and formed a ring that would float above the wand. And as we moved the wand, the ring would move with it. Okay, kind of like that. Now, we've discussed a little bit with our neighbors and done our own drawings explaining what we think has happened, okay, and come up with a variety of questions that we had discussed. Okay, and this should have led us in as a class to discuss static electricity. Okay, so you guys should have studied static electricity last year. Okay, and if you remember, electricity is the movement of electrons. We're going to use this little E with a negative sign. Okay, so we'll use this little E with a negative sign to be our symbol for electrons. And electricity is simply the movement of electrons from one location to another. Static, however, means to not move. So that means that we have an excess of electrons in one location. Okay, so here in our ring, we actually have, it is actually full of electrons. Let's write that with a thinner line. There we go. Full of electrons. And electrons, electrons we know, like I said, can move around and create that static moment. Okay. But that doesn't fully explain what it is that's happening. Because electrons, once again, I'm going to change that thickness there. Electrons, they have they are what we call a subatomic particle. Okay, they're a subatomic particle, and that means that they are sub, meaning smaller than, atomic for an atom. So they're smaller than an atom, and these electrons, because they are so small, can actually move away from their given atoms and fill the aluminum ring. Now, subatomic particles actually have a charge. Okay, so we know that electrons are a subatomic particle. We know that they have a charge. In fact, we know that it is negatively charged, or has a negative charge. Okay, has a negative, I wrote change, charge. There we go. Okay, we know it has a negative charge. Now, if, just like with magnets, if I have a negative and another negative, which is what's happening here with our rod is also filled with negatively charged electrons. Those negative charges will oppose each other and push each other away. Okay, and as they push each other away, then that makes it so that we can move our wand, and the ring moves away with it. Okay, where if we move the wand, the ring begins to just fall like normal. Okay, now here's the thing: is there's more than just one subatomic particle. In class, we discussed what our different subatomic particles are. We have electrons, which are the ones we looked at here. The other two, because there are three of these subatomic particles, are protons and neutrons. Okay, protons, neutrons, and electrons. All three of these are subatomic particles. Let's talk about our charge as well. So, in fact, we could probably go like this. I'm going to go ahead and copy and then paste this here and here, okay, to symbolize that these are both subatomic particles. Okay. Protons, however, do not have a negative charge. They have a positive charge. Okay, you can think P for positive, P for protons. Okay, that's how we'll remember that. And then our neutrons have what's called a neutral charge. Okay, what that means, neutral means it doesn't have a charge. It is not negative, it is not positive, it is neutral. And for that, we can think neutral neutron. Okay, you see the very similar root to both of those words. Neutrons are neutral, P for positive, and then electrons are negatively charged. Okay, and all of these particles are quite small. However, size is all relative. Sometimes in class, I'll make the joke that, I might be a fairly big guy compared to some of you, but if you stood me next to Andre the Giant, who was in The Princess Bride that we watched the other day, he was 7'4" and 500 pounds. So if you put me next to him, you'd see that I am much smaller than he is. Okay, so size is all relative. It's all about comparing the size of one thing to the size of another. So if we look at protons, neutrons, and electrons, their size is all relative to one another, and that's what is important there. Okay, not whether or not they are small or large in our normal frame of reference. Okay, so we want to consider the size of these particles as well, which is why I'm making myself a little bit of space here to be able to fill in our notes. Okay, so protons and neutrons have a very similar size. In fact, there's a unit we use just for subatomic particles and atoms called an AMU, okay, also known as an atomic mass unit. So that's AMU for atomic mass unit. Okay, so a proton has a mass of roughly 1 AMU. Okay, of 1, not roughly 1, of 1 AMU. Okay, then let's erase my drawing here. Then neutrons have a mass of approximately 1 AMU, meaning that protons and neutrons are essentially the same size. Though if we're being technical, neutrons are a tiny bit bigger. Okay, and then electrons have a mass of approximately 0 AMU. Okay, meaning that electrons are very, very, very small. Now, that doesn't mean that electrons do not have any sort of mass. They do, but it's a very small amount of mass, and so it doesn't really count towards anything. Okay, so we've got our subatomic particles here: protons, neutrons, and electrons. Now, there are different parts to an atom as well. You may have seen atoms in online or textbooks or things like that. Okay, kind of look like this. They've got this central nucleus, and then they've got electrons, okay, that orbit around the outside. Okay, and maybe they'll have orbits in different orientations. Okay, that move around as well. Okay, kind of like something like that maybe. Okay, maybe you've seen atoms represented in that sort of regard. Okay, now we can use this, though this picture is not accurate, we can use it to help us identify the two main parts of an atom. This center region, this big region right here, we call the nucleus of the atom. Okay, nucleus of the atom. Just like last year when you guys studied cells and it talked about the nucleus of the cell, which is where all the DNA and RNA is located, that important information for a cell, the nucleus, meaning the center, is where all of the mass is located. Okay, within the nucleus of the atom is where we find protons and neutrons. So we would say protons and neutrons are found, let me move over a little bit, in the nucleus. Okay, protons and neutrons are found in the nucleus. Then, out here on the outskirts, okay, we have our electrons. Okay, all these different electrons everywhere. And electrons, they're in this area we call the electron cloud. Okay, and that's where we find electrons. Okay, and electrons are actually really interesting because they are so small and they move so quickly. You actually can't pinpoint exactly where an electron is going to be. Instead, you just say, okay, there's this region that electrons could be found within, and they're somewhere in that region, okay, which is why we call it a cloud, because a cloud is just a shape that represents an area in this case. And then, let's see. So that's our kind of our explanation here, where these subatomic particles are found, what they are, how big they are, what charges they have. After this, and you've filled out the questions, there's one last video for you to watch called The Size of an Atom. Okay, and we'll look at that as well here at the end of class, the size of an atom.